Last week we discussed the topic of variables and functions. So we have a way of storing information in the computer and we can write code that manipulates this data, and some of that code can be encapsulated in functions, so we can reuse the same code at many places in the program. One other feature that, other than storing data and manipulating data, another thing that computer programs do all the time is make comparisons or check conditions. If I write a program that will advise me, an app on the phone that will advise me whether it's a good day to go sailing, I might want to check whether the weather is nice, I might want to check whether the sun is shining, I might want to check whether there is enough wind. And if so, it might advise me to go sailing, and otherwise it might advise me something else. If I have a computer simulation, I might check whether a particular party is the closest to me or not, and if so, if it's the closest, I vote for it. If it's not, I won't. Conditions are there throughout computer programming. If I ask a user to enter a password, I might check whether the password is correct or not, and if correct, I take one action, and if not correct, I take another action. So, a key to understanding computer programs is to understand how to deal with conditional statements. And so this week we will talk about conditional statements. We already discussed the data type Boolean, which is true or false, and which only has two values. And so when we have a conditional statement, we also tend to have a true or false outcome. And we can then write a program around this. Usually the statement that we will see is an if-then statement. If the condition is true, then do the following. If not, then do something else. That shape of function is what we will see throughout this video. And the second one I will look at the end is something that is called a while loop. Something that keeps repeating, keeps running over and over while a particular condition is true. So we will look at the for then else construction, the if then else construction. If the condition is true, then do X, else do Y. And we will look at the while construction. While the construction is true, keep repeating this loop. So while it is nice weather, I might keep walking here. And if the weather is nice, I might go for a walk. When we make conditional expressions in Python, and when we want to see whether something is true or false, we often compare two items. We compare two items for whether they are equal or whether they are unequal, whether one is greater than or smaller than the other, etc. We can also have true or false outcomes from function calls, for example. So sometimes one variable is enough, but more often than that we make these comparisons. And when we make a comparison in Python, we have the following syntax. To check whether two items are equal to each other, we use two equal signs. And please note that there are two equal signs, not just one. For a lot of programmers, even more experienced ones, this often leads to confusion. So one equal sign is an assignment operator. For example, A equals 5. Two equal signs is a comparison operator, and it compares whether the left is equal to the right. For non-equality, to see whether two items are different from each other, there are two different symbols we can use in Python, and they can be used interchangeably. The first one is the exclamation mark equal, and the second one is the greater than and less than combined. This means not equal. So this function is true if the left is not equal to the right. And then we have the comparison in size that work more for numbers. So we can do greater than if the left is strictly greater than that on the right, or greater than and equal combined, which means that the left is either greater than or equal to that on the right. And the same for less than. We have a less than symbol that means that the left is less than that on the right, or a less than equal sign, that is the left symbol should be less than or equal to that is what is on the right. I will show you some examples in the Python code, but this is just an overview of the different comparison operators. Let me try to show you quickly how these comparators work in Python. So normally we use them in if statements or in while statements. Here I'm just going to print the outcome, so we will just print true or false, just so you have an idea what kind of results you get. So to show you, I'm going to just go to the whole list of comparators, and we do it with two random numbers that we draw between 1 and 100. So we import the random library. We have a random number A, that is a random integer between 0 and 100, and B, which is also a random integer between 0 and 100. And I'll first just print the two numbers. Yeah. So we use the D there in format for integers. So this is a simple program that draws two random numbers and prints them. And we don't know anything else. So let's look at the different comparisons. So I'm going to each time just type the equation that we want, just to print it, and then print the result of it. Yeah? So for example, equality would look like this: A equals B, and we can see what the result is. Yeah? If you run that, then A equals B is false. Yeah? And we can do that for all the comparisons that we're interested in. Yeah, we can do it for A is not equal to B, and see what the result is. Yeah? And A indeed is not equal to B. Or we can use it for greater than or smaller than. Yeah, and we get the expected results. So with 36 and 55, 36 is less than 55, so A less than B is true and A greater than B is false. And then we can also repeat that with including the inequality. And there we have all the main comparators. Yeah, so if we have 30 and 6, then 30 is not equal to 6. So A equals B is false, A is not equal to B is true, A less than B is false because 30 is not less than 6, A greater than B is true because 30 is greater than 6, and A is either less than or equal to B, so 6 and 30 are neither equal nor is 30 less than 6, so it's false, and finally you get true. Yeah, so this is how the comparators work in Python. Let's look at an example of using conditionals in a Python program. So let's think of the US elections maybe as an example. So I'm going to use the random library again, just to show that the program has a little bit of a surprising result. We don't know yet what the outcome is going to be. And let's say we say that the percentage of votes for Trump is a random number, and it's always between 0 and 1, and because it's between 0 and 1, maybe we multiply it by 100. So we get the percentage. And the percentage of vote for Biden, let's keep it simple, is 1 minus the percentage of the vote for Trump. Yeah, so the percentage vote Trump is a number between 0 and 100, and the percentage of vote for Biden is the exact reverse of that, the 100. My apologies, 100 minus the percentage that is for Trump. And then we can print the result. Yeah? So if percentage vote for Trump is greater than percentage vote for Biden, then print Trump wins the election, else print Biden wins the election. So this if and else statement here, that is very common in computer programs. So we have the if statement, we have a condition that we try to test, and then we have a block of code. Blocks of code in Python are always separated with indentation, so through the white space here we know that this is one block of code. And this block of code is performed if this is true. If the percentage of votes for Trump are indeed higher than the percentage of votes for Biden. If it is not true, then this piece of code is run. Then we go to the else condition. So this format, if condition, the true block of code and else false block of code. Yeah, so this is executed when the condition is true, and this is executed when the condition is false. But this is of course not good Python code, so I delete this. And we can run this and we get the result. Biden wins the election if we run it the first time, Biden wins again the second time, Trump wins the third time, etc. Now this of course gives them an equal chance. I'm expecting that not to be true, but this is just what we have now. Maybe we actually want to also see what happens, right? So we can put, we can display the result. Point 1. And then we do the same here. So now we know that also the result, right? In this round, Trump wins the election with 90% of the vote, the next round with 53% of the vote, then Biden wins with 53% of the vote. Yeah? So formats can be used to display numbers, and then here you use a D for integers and an F for floating point numbers. But don't worry about that too much, it's just an example here. The important thing is the if statement, and then the code that is executed when if is true, and else the code that is true when the statement is not true. And note that we can always have multiple lines of code here. So we can also say winner equals Trump here, and winner equals Biden here. So now we have multiple lines of code in the same statement, and this is fine, right? So we can say here, so the winner is very silly example, but it shows you how these if statements and else statements work. There is one more option here, and that is to have also a second condition. So there is a so-called elif statement, but I will not go there today. So I want you to get familiar with the if and the else construction. Yeah? So we could have had if percentage vote Trump greater than 50, then the winner is Trump. Otherwise, if the percentage of vote for Biden is greater than 50, winner is Biden. And then the leftover, if neither of those two is true, then neither of them has won the elections. Yeah? That could be one argument. So here we have an if statement with one condition, an elif statement, which is a combination of else if. So this statement is not true, but I want to put another condition. So if the percentage of vote for Trump is greater than 50, then the winner is Trump. If the percentage of vote for Biden is greater than 50, then the winner is Biden. And otherwise, so if neither of those is true, then the winner is neither Biden nor Trump. In addition to the if statement, I also want to introduce the while command. The while command is similar to if in the sense that it is about a condition, but where if is evaluated once. If the condition is true, we execute one block. If not, we execute the other block, the else block. The while statement keeps running over and over the same block of code until some condition is not true anymore. So we could give an example with throwing a dice. So I'm going to use the random library again, and I'm going to write a quick function that is throwing a dice. Yeah, throw dice, return random 1, 6. Yeah. So this is a little function that throws a dice and returns a number 1 to 6. And now we could make a loop that keeps throwing the dice until, say, we get a 6, and see how long it takes. Yeah? So we can say number of throws is 0 to start with, and the last throw is a no, it doesn't really matter what it is. That's just a random number. So we can say while last throw is less than 6, we throw the dice again, and we print the dice throw, and we might also print, we add the number of throws to the number of throws. So this adds the number of 1 to the number of throws. And then at the end we can see how many throws we used. So let's run this. Yeah, so we threw the first round, we threw a 1. Now this is not this 1, this is just a random number. It's immediately overwritten in this line. So here a new dice is thrown. So this prints last throw, which with this 1 on the screen is after we threw the dice here. If I run again, the first number will be different. Yeah? Now it's a 2. So as long as this last throw is less than 6, we keep throwing the dice. Each time we print the dice throw, and we add 1 to the number of throws. So this is like a counter. Count the number of throws, and each while loop we add 1 more. And so then we know that it required 11 throws to end up with 1 6. Yeah? If I throw again, now it took only 7 throws to get a 6. Only 2 throws, and we already had our first 6. Another 2 throws to our first 6. This time the first throw right away got us a 6. Yeah? So we can experiment a bit, and we can run this simulation many times. This is like a simulation because we're drawing random numbers and we are evaluating how long something takes or what happens. So this is an example of a while loop. This condition, as long as it's true, we keep repeating the block of code that follows the while statement. And the moment this becomes false, so the moment we throw a 6 and last throw is not less than 6 anymore, we move on to the code that is after the block, and this is not run again. So the moment 6 was thrown, there is no new throw, no new number that is printed, no number that is added to the number of throws that it took. And that's right, because this 6 is indeed, these are indeed 6 rows. Yeah? So there are 6 times a number printed. So when the moment this condition became false, we moved to this last sentence of the code, which printed the count that we had of the number of throws. So this while statement is very powerful. There are some other ways of making loops in Python that are more often used. So while is maybe not the most commonly used, but all the other loops can actually be simulated, be emulated by just using the while statement. So by only understanding the while statement, you can make any kind of loops that you want in Python. So this is quite powerful. While in many cases we might be looking at basic statements of equality or inequality, if the temperature is greater than 20 degrees, if rainfall is less than 20%, etc. We sometimes look at more complicated statements, and we often combine conditional statements. So good weather might be described as if the temperature is high and there is low rain and there is not too much wind, etc. So we get a combination of statements that either all need to be true or where some or one of them needs to be true for a certain action to be taken. And so we often combine conditionals through AND statements or statements, and we can also negate statements with the NOT command. So we can say if the weather is good, or we can say if the weather is not bad. And we can make AND statements to combine. Where with an AND statement, all conditions need to be true for the overall set to be true. With an OR statement, either one needs to be true for the whole statement to be true. So there are tables for that to show you how that works, which I will show in the slides. But the key here is that we can combine in complicated expressions different conditional statements, and this is quite common in computer programming, and we will use this regularly. And in fact, there is a whole field of algebra around these statements. There's a set of rules that one can apply to simplify complicated statements based on conditionals. We will not go into that algebra, but just so you know that there is this field. As I discussed, sometimes conditional expressions are built up out of different blocks. So rather than just stating if X is true, then perform the following action, when we look at equality or inequality of two items, we often combine different conditions together in one statement using something called Boolean algebra. And there are 2 or 3 operators in Boolean algebra that are particularly important: the AND operator, the OR operator, and the NOT operator. So when we look at the AND operator, we get the following truth table. If 2 statements are false and we put an AND condition in between, then the result is also false. If either one of the 2 is true but the other is false, as in the second and the third line here, then with an AND statement the result is also false. The only case in which an AND statement is true is if both the left-hand side and the right-hand side are true. So if condition A is true and condition B is true, then the combined condition is true if we have an AND operation. So with AND we can make sure that 2 conditions are true. If I want to find a cheap book, I can check that the product I am looking at is a book and the price of the product is low. And if both are true, then I am looking at a cheap book. However, if it's either not a book or it's not cheap, then I should obtain false. If it's neither a book nor cheap, then of course it's not a cheap book. The counterpart of this OR AND operation is the OR operation. So in this slide we have the OR operation. And you see that now if either one of the 2 is true, we get a result that is true. So I might check products for a store, for a bookstore, and check whether something is either a magazine or a book, then it's a suitable product. If it is neither a book nor a magazine, then it might not be suitable for this store. And if it's a book that can be sold as a magazine as well, then of course it's very suitable for this store. So with OR, either one of the 2 conditions has to be true, and with AND, both of the conditions has to be true. And the only smaller operation and the easier one is the NOT operator, which basically just negates the condition. So it gets the opposite. Something that is not false is true, and something that is not true is false. So these 3 tables, they are crucially important to memorize, to always have clearly in mind. So for AND, both conditions need to be true. For OR, either condition needs to be true, or both conditions can be true. And for NOT, the condition has to be false for the result to be true. Now, there are actually complicated rules around this. With parentheses and different conditions, we can make very complicated expressions. You can think of something like this. If either condition A or C is true, and A and D is true, or A but not D, etc., we can make very complicated conditions. And there is actually an entire algebra, a set of rules how we can manipulate these kind of equations so that we can try to simplify them. For example, this complicated expression, once you apply all these rules, boils down to either A or C is true. And then we have the result. So whether you use this complicated expression on top or the simplified A or C, you get the same result. Of course, if you program this in Python, the first will be much more convoluted, the last will be much simpler. But the first might be easier to read because it's closely aligned with what you're thinking. The last involves a lot of algebra to get there, and readers of your code might not understand what's going on. In any case, Discussing the rules of Boolean algebra is far beyond this course and not something I want to discuss. I only wanted to just state that there is this kind of algebra, that it exists. So if you see somewhere a reference to Boolean algebra, they are talking about this, deriving from a complicated equation to simplification. The part that you really should know, that you need to know when you do Python programming, is the truth tables that were in the first few slides. So we had this example before where we look at the beginning of this video where we had a number of comparators and we just printed what the comparator does. So we can actually expand this to maybe compare with 3 numbers and show how this AND and OR works. Yeah? So we draw a random number again between 0 and 100. We print this as well, just like we did with A and B. Yeah, so far we have the same program. We draw 3 numbers, but then we compare only 2. And then we can make additional comparisons, right? So A equals B, or B less than or equal to C, for example. I can just take this expression and compare it. Yeah? So either A is equal to B, which is not true, or B is less than C, which is true, and then, so because it's an OR statement, only one of the two has to be true, so this is false, and this is true, but because it's an OR statement, that means that the result is true. A similar example, prints A less than C and B less than C, right? So both A and B should be less than C. This is what we're testing here. So in this case, A and B are 1 and 2, so they're both less than 50, so this is true. If I run again, now A is greater than C and B is also greater than C, so both conditions are false, and this is definitely false. And if B is larger than C and A is less than C, then it's also false, because it's an AND statement. So you can experiment a little bit with these kinds of lines of code just to understand fully how these conditional statements work.